Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi to all. So in part 1 we have stopped until this example 2, and for this example 2 is that you are given this signal xt e minus at ut for a more than 0. So what you need to find to calculate here is that they ask you to find what is xj omega, so which is basically to find what are the Fourier transform for this signal. So you are going to prove this xt signal, convert it to Fourier transform using this equation. Here we are going to solve for example 2. So based on the given example, so consider the signal given by xt equal to e minus at ut. So a is more than 0. So it means that you have the signal for e minus at ut given by this graph. So find the Fourier transform x j omega. So when you want to find the Fourier transform for the signal xt, you're going to use this equation ft. So Fourier transform. So xj omega is given by the integral of from minus infinity to infinity xt e minus j omega t dt. So this is the general equation. So what you need to do is that you need to substitute what the value that you are given, which is xt here, into this equation. So you have here xj omega equal to, okay, for the integration part, so you need to refer to this graph. So what you see here is that the graph is given by a more than 0. So a more than 0 means that the signal will start from 0 until the infinity. So that's why you have the integration from 0 until infinity here. And then for the value for xt value is this signal itself. So the xt value is given by e minus at. So this one is the signal for xt. So e minus at, this one is the general equation, e minus j omega t dt, right? So you then group it together, which is you will expand it, you will get e minus in bracket a plus j omega t dt. So from here is that you need to get the solution for this integration. So you will get this equation here. So when you substitute for infinity and 0 into this equation, you will get the final answer is this one. So this is actually how you elaborate or how you prove the equation given by xt e minus at. The Fourier transform is given by this equation. So another solution is that you can actually directly use the Fourier transform table, which is given by e minus at ut. So this one is a table. So this table refers to the appendix that you are given. So find e minus at ut. So which is this first equation, e minus at ut. So directly, if you look at this row here, this row, so you see that this row is xt and this row is x omega. Means that this one is the signal in time domain and this is the signal in Fourier in frequency domain. So which means that this one is how you are going to get the Fourier transform. Fourier transform here. Okay, so x omega is the Fourier transform. So directly from here you can actually get your answer is 1 over a plus a j omega, which is equivalent to this one that you have actually proved in the beginning, right? So next we are going to go to example number 3. So example 3 is given by this equation. Xt is equivalent to E minus AT ut for A more than 0. But however, if you see here, the value for AT is given by T, which is the modulus value. So which means that you are going to have the value in both sides, negative and positive side, for the time domain. So what you're going to do is that find j omega here. Prove using equations, the general equation given here. So let's do this example. So when you're going to, based on this example, okay, the solution for this example is that first you need to refer to the equation given. So the equation given is E minus AT modulus T, EUT, means that you're going to have the value for the positive side here and the negative side here. So first of all, you need to understand how to plot this equation when you are given this exponential value. So let's say we refer to this general exponential signal, which is you have learned in chapter 1. Okay, so let's assume that you have, sorry, I will changing color. So let's say that if you have the signal given by C, E, A, T, so where C is the amplitude. So for this case is that C is equal to 1. Assume that C is equal to 1, so that's why you have the value here 1. Okay, so E, A, T, so A. So refer to this one. A equal to 0, then you will have a decaying exponential in the negative side here. So means that you're going to start the signal from this one decaying down or moving up. So it will cross at y-axis at 1 value. Okay, and let's look at another example, which is when you have CE minus AT. So C is the magnitude here, so C is here, still the same thing, you have the cross-sectional, and you see here that the value for A is less than 0, which is A is minus 1. So it means that you will have the decaying exponential. So for the first one is just now is the increasing exponential, this one is the decaying exponential. So draw the decaying exponential starting at y-axis equal to 1, moving down, which is decaying down, and it will start from above, of course, because it's an exponential signal. So you have this signal, right? So when you combine this, you will get this signal for E minus A modulus T. So which means that you have the cross-sectional at 1, because here is C is equal to 1. So you're going to have, for the positive part is that it's going to decay down, and for the negative part is that it's going to increase to 1 and actually cross at and meet at 1 equal to the value 1 here. So this is how you plot for this signal. Why this is important is that because you need to know later what are the value that you need to integrate it. So you have this value at 0, okay, and you know that at the negative part here you have the value at minus infinity, and for the positive part is that you have it at positive infinity. So what you need to do is that we need to actually divide this into two parts, which is this one will be the first part and this one will be the second part. So let's just do this example. So find x, j, omega. Okay, So using the equation, the general equation given here, so this one is the general equation. You will see that you have from minus infinity to infinity xt e minus j omega t dt. And what you know is that xt is actually the signal. So that is why we need to identify which one is the signal for ce minus at and ce at. So we have identified just now that E minus ET is on the positive side of this graph, and CEAT is on the negative side. So this would be easy for you later to do the integration. So based on this equation is that you need to divide it into two summation points. So the first point is that you will integrate this from minus infinity to 0. Why? Is because you know from this graph you can see that from minus infinity to 0 you have the graph for EAT. So that's why you have xt here is EAT, and this one is e minus j omega t is based on the general equation. Okay, so dt plus from 0, integrate from 0 until infinity. Okay, you have this equation, okay, which is e minus at, right? So time multiplied by e minus j omega t dt. So you have actually finished the hard part of this example. So next what you need to do is that you need to solve for this integration. So when you solve for this integration is that before that, as the what you have done in example 2 is that you need to group it together for a minus j omega here. Okay, group it together, and this one also you group it together, right? So when you solve for this integration, you will have equivalent to 1 over a j omega plus 1 over a plus j omega. So you have the first part is that you have minus j omega, second part you have the plus j omega because of the different exponential value that you have here for both equation. Okay, expand it, and then finally you get the final equation as 2a over a squared plus omega squared. So this one will be the final proving for this type of exponential signal which you have the modulus signal. So similarly to example 2, you can solve this equation by using or referring to the table. So let's go to and see to the Fourier transform table. So based on this example is that it is referring to the equation number 3 here. So directly you see that xt is equal to minus a modulus t. So you have here the Fourier transform given by 2a over a2 plus omega 2, which is similar to this proof just now. Okay, so this one will be the final answer. Or if you look at this point of the equation, you can take this out and then you refer to this point. And by having this, you can actually directly see that this two equation is similar to this two equation here, which is for the positive exponential and the negative exponential. Okay, now now we are going to do the example 4. So example 4 is find the Fourier transform Vt and draw its frequency spectrum. So you are given the signal Vt here, and you have the value of the rectangular signal from minus tau over 2 to t tau over 2. So that's why you have Vt here is as V naught is a magnitude V naught here, and you have the t value from minus tau over 2 until tau over 2. Okay, and for the other value as we have 0 point. So let's just go and get the Fourier transform using this equation, general equation. So for the solution is that first we are going to use the general equation for Fourier transform. So for the Fourier transform, we are given the general equation, which is we have to integrate it from minus infinity to infinity. So you have the value for minus infinity is you have from minus tau over 2 until tau over 2. So that's why you have the value here negative tau over 2 to tau over 2. And then next is for the value xt, here you have the value which is, what is the value for tau minus tau over 2 to t tau over 2. So you have this value, right? So it's at v naught. So you have the magnitude value. So in the case of the value for v naught is equal to 2, so that's, so meaning that you write here 2. Okay, so e minus j omega t dt. Then you do the integration for this v naught, then you will have this equation. So v naught, take out this v naught outside, and then v naught e minus j omega t over minus j omega from tau over 2 to minus tau over 2. Then in order for us to actually, we would like to try to transfer or this equation become using Euler equation. So it's either in sine theta or cosine theta. So let's say that if you look at this equation, okay, the denominator here is you have j omega, so means that this can be a sine wave signal, sine theta signal. So meaning that for sine theta, if you see the origin signal, so sine theta is that you have equivalent to ej theta minus over 2j. Okay, ej theta minus 2 minus j theta over 2j. So you do not have the value for 2 over here. So that is the reason why you multiply this equation by 2 over 2, so that you have 2j in the denominator. Okay, so once you have this 2j, means that here you will have it 2, and this omega, take it out over here. So you will have this equation as sine omega tau over 2, and this one is 2 v naught over omega, so which is this 2 will be at this point. Sorry, you have 2 over here, right? Okay, so you will have the equation 2 v naught over omega sine omega tau over 2. But here is that if you see here, if you can able to transfer this equation sine theta to sin theta. So to do that is that you need to have the numerator as omega tau over 2. So you have omega over here. So it means that you need to multiply this equation with tau over 2 over tau over 2. So you will have the numerator omega tau over 2, which is similar to this value. So that's why end up you will have the equation v naught tau sin omega tau over 2 as the final equation. So from here is that the equation also asks you to draw the frequency spectrum. So in order for you to draw out the frequency spectrum is that you need to determine what is the main value. So you have the v naught, which is the magnitude, and also from here you know that you have the omega t, which is t equal to tau over 2 here. So take these two value out, and you can start drawing out the sin wave form. So start by plotting first the magnitude v naught tau here, and then you have this value. Okay, this value is given by minus tau over t, and you know that t is tau over 2 here. So and now you will have this 2 pi over tau. So you have at this point 2 pi over tau, and at this point minus 2 pi over tau. Then you can draw out the waveform for sin waveform. So let's say I plot it So you can start to plot from here and then this point. Okay, so this is how you solve for this type of question. Okay, next we are going to do exercise number 1. So given a signal xt which is defined as cos 2 pi f1t. Cos 2 pi f1t. So meaning that you have here is omega 1t. If you change the value or substitute the value for 2 pi f1, you can substitute as omega 1. So you have omega 1t here. Which is from minus t over 2 to t over 2. So this waveform, the y-axis is not correct. You should have your y-axis at this point. Because it's a cosine waveform. So you have from here this point. So t minus t over 2. T over 2 is at this point. And minus t over 2 is at this point. Okay, so find the Fourier transform for xt. So this one, it will be a bit complicated, but it's if you know the basic of a Fourier transform, you can actually solve for this equation, for this question. So let's go to the solution. So first of all is that you're given the signal as given in the previous slides. So here is I draw out the equation. So you have it at 1 because you don't have any magnitude value. So the magnitude is 1 and you have the cosine wave given here. So we have from minus t over 2 to t over 2. So find j x j omega. So let's say to make this calculation simpler, because if you use 2 pi f, it will be a bit complicated. So I would like to substitute omega with 2 pi f. So in this case is that we substitute omega 1 as 2 pi f1. And then we do the Fourier transform using the general equation. So let's start to do this equation. So by using Euler is that you are going to have the integration minus t over 2 to t over 2. So using Euler, expand this equation. So you know cos omega 1t can be expanded to this equation. Ej omega 1t plus minus e minus j omega 1t over 2 e minus j omega t. Then we expand it again. For this case, I separate it out, become two different equations so that it will be easier for you to understand. So I separate it out by having the ej omega 1 minus omega t over here, and another one is that minus j omega 1 plus omega in bracket t. And then you do the integration, so you will get this equation. So when you integrate, you will have this for the case of this fundamental frequency, you have omega 1 minus omega, and for this case is that you have omega 1 plus omega. So the difference is that the plus minus symbol here, and then you expand it, you will have this equation by substituting t over 2 to minus t over 2, and you have equation roughly like this. Okay, it's a bit long. Well, try it out, you will get this type of equation. And from here is that we want to transfer it again into sine wave equation using Euler. So we change it again. So you see that you have the denominator j here. So what you need to do is that you need to find out what do you have the 2j. So you have the 2j here. So you can directly transfer it into Euler using Euler identity. So you will have 1 over omega 1 minus omega dot sine omega 1 minus omega t over 2. Okay, don't forget this t over 2 is the symbol, is the exponential equation here, plus 1 over omega 1 plus omega dot sine omega 1 plus omega times t over 2. So from here is that we want to try to reorganize again into sync signal. So sync signal is that you have omega 1 minus omega over t over 2. So because of that, we would like to multiply these two equation by t over 2 plus t over 2, so that the numerator you have the t over 2 part here. So when you multiply t over 2, you will have the answer t over 2 sync omega 1 minus omega t over 2 plus t over 2 sync in bracket omega 1 plus omega t over 2. So from here is that you can see that you have two different fundamental frequency. So the first one is that you have the omega at omega 1, which is on the positive side of the x-plane. And another one is that you have the omega at omega minus omega 1 at the minus negative plane. So let's plot it. So when you plot it is that you have these two different omega. So try to plot first is that identify the value for the magnitude. So the magnitude here is that you have t over 2 and t over 2. So both are the same. And then you have the frequency at omega 1 and minus omega. So plot this one. This one will be the center for this sync signal. Okay, so this one will be the center for minus omega. So this one. And then this one for omega 1 will be for this signal. Right? So, and then identify what is the value for t. So because you know that at this point over here, this point, wait, I changed the pen. So you know at this point you need to use this equation to set the value for the x-plane. So you have the value given by pi over t, and t value is based on your original equation here. So directly you can see that the t value is t over 2. So end up you have the value here is 2 pi over t. So this one you have 2 pi over t. Right? So this is how you plot the frequency spectrum. Means that you have two different sync signal on this plane. So you have omega plane here, and then you have the frequency for xt omega. So some might ask, why is the in the previous example 1, 2, and 3 your sync signal start from 0? Well, you see that the plotting start from 0 because you do not have any omega 1 here. So it means that you only have omega. So you have omega means that omega equal to 0. So that's why it will start at 0 at this point. Okay, so that's the difference.